Okay, hi everyone. Here, I'm going to post up a video here for your first set of notes. As I mentioned in the email and in the video earlier, we are going to kind of pause what we were working on before this little break. We were simplifying rational expressions, and we will come back to that because you will see that stuff on your final, but we had just taken that quiz. It was a good time to just kind of break. After that, we were just going to review and take a test, but that's kind of hard to do while we're doing e-learning. So we're going to go ahead and jump into the next unit, which is all about solving systems of equations. We start this systems of equations by solving by graphing. A quick little kind of background on what a system of equations is. Basically, a system is like a working thing together, right? Like if you think of any other kind of system, it's different parts working together. So a system of equations is basically just more than one equation that are all working together. Another basics with it is the number of variables that you need to solve for. That's the number of equations that you have. So a lot of times we have more than one variable in a problem. Sometimes we don't know how long something will take, and we also don't know how much something will cost. That's two different variables that we have to make work together. So we need two different equations to model that situation so that we can solve for both variables. There are all kinds of applications of system equations to things in the real world. Think of how a factory works and how that belt works and how they're putting things together in a factory system. That is all about systems of equations. There's so many variables there. There could be hundreds of variables, which means I have hundreds of equations. They're all being solved at the same time to make sure that everything happens in the right order. Okay, so in Algebra 1, we focus on just two equations, so two variables. Algebra 2, you'll do some three-variable systems. But to start, we first need to see what a solution of a system is. So like I said, we've got more than one variable. If I have an x and a y, I'm going to get a solution for x and a solution for y. And those two numbers go together to make one solution to our system. So if I have an x and a y value that go together, that's an ordered pair. That's a point. So a solution to a system of equations in two variables is an ordered pair. And that ordered pair satisfies each equation in the system, meaning that it's a solution to both of the equations. So if I want to find out if something is a solution to a system, for example, this first one, we've got the ordered pair 5, 2. I want to know, is that a solution of the system of equations, which is both of those equations together? Basically, we're just going to substitute that ordered pair into each equation and see if it works for both. The only way it can be a solution is if it works for both equations. Okay, so we'll start with testing our first one here. And remember, this is your x value and your y value. So you plug them into the right places. So I'm going to do 3. And I'm going to substitute in 5 for x, minus 2, and I'll substitute in 2 for y, equals 11. We do the math on the left side. That's 15 minus 4. 15 minus 4 is 11. So 11 equals 11. That means this works for our first equation. Okay, there's our first check. So now we'll check our second equation and do the same thing, plug in that same ordered pair. So I add a negative, I'm going to plug in 5 for x, plus 6, and I'm going to plug in 2 for y, equals 7. That's our second equation. That would mean negative 5 plus 12 equals 7, and negative 5 plus 12 is 7. 7 equals 7, so it also works for the second equation. Because that ordered pair is a solution to both of those equations, then yes, the ordered pair 5, 2 is a solution to the system. And you don't have to write out that whole sentence. You can just say yes, but just so we understand what that means, that that is a solution to the system. That means basically this point, 5, 2, is a point on both of those lines. It's a solution. Okay, same thing for our next example here. We've got an ordered pair. We're going to plug into each equation. So our first one is x plus 3y equals 15. Here's my x and my y. So I'll plug in 3 for x plus 3 times negative 6 for y equals 15. And then if we go through that, that's 3. 3 times negative 6 would make a negative 18. 3 minus 18 gives us a negative 15 equals 15. Negative 15 is not equal to 15. They're the same value, but one's negative, one's positive. So that is actually not a working solution for that first equation. Now, if our ordered pair doesn't work for the first equation, it doesn't matter if it works for the second equation. It's definitely not going to be a solution to the system because it can't be an ordered pair that works for both. So we can stop. If you get the first one wrong, you don't have to test the second one. You can stop right there and say that no, 3, negative 6 is not a solution to this system. Right? Sometimes you'll check the first one and it will work, and then the second one won't work. So that would also be a no. The only time you're going to say yes here is if it works for both equations. So this ordered pair, 3, negative 6, it is not a point on this first line, so it can't be a solution. Okay, so that's how to check your solutions. All right, when we're graphing, we've got 3 different things that can happen with systems of equations, and not just when you're graphing, but we'll see this in our graphs. There's 3 different things that can happen. The first and most common thing that we'll see happen is we have one solution to our system. One solution, just like we did in our example up here, means that that ordered pair works for both of the equations. And remember, that means it's a point on both of those lines. Now, if that point is on both lines, then that point is where those 2 lines intersect. So your solution is right there where those 2 lines intersect. Our 2 lines intersect or cross. And that gives us our one solution of an x value and a y value where they cross. Something else that can happen is we can end up with infinite solutions. This happens when we go to graph our lines, and I graph the first line, and then when I go to graph the second line, it actually graphs right on top of the first line. So now if I have 2 of the exact same line and I graph them, how many places do they intersect? Well, they intersect everywhere. All of their points are the same. So these 2 lines are overlapping. They have infinite solutions, right? So all the points on those lines are the same. And the last thing that can happen is we can have no solution. No solution happens when, look at those lines, what are they? Those are parallel lines, right? Parallel lines means they never cross. If they don't ever cross, then they can't have a point that is in common. So that would be no solution at all. Okay, so those are 3 things that can happen. One solution, infinite solutions, or no solutions. And we'll see that with graphing and also when we start solving them algebraically. Okay, so let's try a few here. We'll do a couple examples together. So we're going to basically solve this system of equations by graphing each line and then looking for where they intersect, if they intersect. Okay, so to solve our first system of equations here, I've got our 2 lines. Our first one is y equals x minus 2. So remember, to graph a line, we've got the easiest way to graph a line is to have it in slope-intercept form. So y equals mx plus b, right? Remember, your b is your y-intercept, and your m is your slope. Right? That's the easiest way to graph a line, is to have it in slope-intercept form. So I'm going to start when I go to graph my y equals x minus 2. I'll start with my y-intercept, which is negative 2. So put a negative 2 and put my point on the y-axis. And then I'm going to use my slope. So remember, there's a 1 in front of that x, and then I can always make it a fraction by putting it over 1. So my slope is 1 over 1, both positive. So I'm going to go up 1 and right 1. And when I'm doing a system of equations, I'm going to fill up my entire coordinate plane. We don't know where these 2 lines are going to cross, so I want to make sure I put as many points as possible. Now, if I go up and right, I can do the opposite. I could also go down and to the left and put points that way. And then you can use a straight edge if you want to, or just do your best to go through all those points. And we got our first line. Okay. All right, and then my second one, I'm going to do the same thing. Y-intercept here is positive 3, so it's positive 3. And then my slope is negative 2/3. Now remember, if you have a negative slope, you can only make one of those numbers negative. So I could make that -2 over +3, or I could do +2 over -3. Both of those will end up the same way. So if I do the +2 over -3, I'm going to go up 2, but then left 3. Up 2 and left 3. And then to go the other direction, I'm going to do the same thing, but opposite. So down 2 and right 3. Down 2 and right 3. And then I'll draw that line. Okay, so then once we've got our two lines graphed, remember your solution, it's a point that works for both lines. So it's the point where those lines intersect. So this guy right here in the middle, that is our solution to the system. That's the point that they both have. So now I just have to name that point. X value is 1, 2, 3, and the Y value is 1. So that's the point where those two lines intersect. That is the solution to our system. If I plug that point into each of those equations, it would work in both cases. Okay, that's what it looks like if we have one solution. Graph each one, look for where they cross. All right, let's try another one. So our next one here, we do the same thing, graph each line. So our first one, I'm going to start with a y-intercept of -3. And then we've got a slope of -2. Again, I can put that over 1 to make it a fraction. So I'm going to go down 2 and to the right 1, down 2, right 1, or I can go up 2 and left 1. And I'll fill up my whole graph here. And then draw your line. Okay. All right. And I'm going to graph my second line. Now my second line here, not exactly how I want it to look, right? I want that to be in slope-intercept form. So I'm going to take that line, I'm going to rewrite it, 6x plus 3y equals -9. And I want to solve that for y so that it's in slope-intercept form. I'm going to subtract 6x from both sides. I get 3y equals -6x minus 9. And then I got to divide everything by 3. So we get y by itself. So y equals -6 divided by 3. That's a -2x. And -9 divided by 3, that's a -3. Okay, so if I go to graph that line, I'd go to -3 and then down to right 1. And look what's happening. That line is actually exactly the same as the other line, right? When I graph this line, I'm going to graph it right over the top of the first one. Now, you don't have to graph that line twice. It's going to be the same exact line, right? I'm just doing it to show you that it's overlapping here, right? And if you look at your two lines in the equations, this y equals -2x minus 3, when we solve the other, we got exactly the same equation. So they are actually the exact same line, which means they're overlapping. So there are infinite solutions here. Okay, now if the question asks you how many solutions there are infinite solutions. I'm going to show you how you actually write what the solution is. I won't really grade you on this too much yet, but I just want you to see what it looks like. What the solution actually looks like, we put it in what's called set notation. I'm going to say I want the set of all of the ordered pairs, x, y, and then this vertical bar means such that, and then I'm just going to write the equation that's up here, y equals -2x minus 3. So that's basically saying that the solution to the system is all the points that are on that line, right? So all the points on that line would work for this system. Again, this tells you the number of solutions is infinite. This is how you would actually write the solution. Okay, so there's what infinite solutions looks like. Let's try another one here. Okay, so our next one, again, same idea. We'll graph our first equation. And by the way, if I didn't mention this earlier, systems of equations is a good one to use different colors. It helps because you can see your two different lines. If not, no big deal, but if you like to be organized like that, you could try using two different colors. Okay, so we'll start with plotting our y-intercept. I'm going to go to +1, and then my slope is +2 over 1. So up 2 to the right 1, or I can go down 2 and left 1. And then we draw in that line. Okay, then I want to graph my second line. Again, that one's not solved for y, so I need to get y by itself. So I'll subtract 4x on both sides. And we get negative 2y equals negative 4x plus 6. And then I'm going to divide everything by negative 2. So we get y equals negative 4 divided by negative 2 is positive 2x. 6 divided by negative 2 is a negative 3. Okay, so our y-intercept on that one will be at negative 3. And then our slope is positive 2. And again, you can put it over 1. So up 2 and right 1. And we go across. And look what's happening with these lines. When we graph that one, you can see that these lines are parallel, right? And if you remember back from previous work, look at the slopes of our two lines. We've got a positive 2 and a positive 2. Lines that have the same slope, those lines are parallel, right? So since our lines are parallel, this system has no solution. Those lines are never going to intersect, so we're never going to find a point that works for both of those equations. Okay, we've got one more example here. This would be a good time if you'd like to pause the video and maybe try this last one on your own. Attempt it and see how you do, see what you get, and then maybe come back to the video and see the answer. So if you want to do that, go ahead and pause, try it on your own, and then come back. Okay, so if you tried it on your own, here's your answer, or if you're going to just keep watching, we'll do this next one. So my first line here, y equals x. Doesn't say anything for the y-intercept, but remember you can always do plus 0. So then my y-intercept is at 0. My slope, there's a 1 in front of there, so my slope is 1 over 1. So I'm going to go up 1, right 1, all the way across my graph. Or I can go down and left 1, all the way this direction. And then we can draw in our line there. Okay, so there's our first line. All right, and then our second line here, again, not solved for y yet, so I want to get y by itself. I'm going to subtract the 2x on both sides. We get 2y equals negative 2x plus 10. Divide everything by 2. So y equals, that'd be a negative 1x plus 5. So my y-intercept, 2, 3, 4, is at 5. My slope is negative 1 over 1. So I'm going to go down 1, right 1, all the way across. Or I can go up and left. And we'll draw in that line. Yeah, it's very straight. Try that one more time, maybe. There we go. Okay, so these lines definitely cross. They have a solution, right? The only problem with this one, or that makes it a little bit harder, is they don't cross on a nice little crosshair for us, right? We usually like to see them cross like right in the middle of the square like that, or on the edges. This one crosses kind of right in the middle of two things, though. So to find that point, it's going to be a fraction, but we can do it. That's about halfway, and this is about halfway, right? So when your two lines don't cross right at a little crosshair, it's best to just do your best to estimate what those fractions are. So my solution here, I'd have to go 1, 2, and then halfway. So 2.5, or you could write it as 2.5, or you could write it as 5 halves. However you want to write that. And then my y value, I go up 1, 2.5, so same thing, 2.5. I won't give you very many problems where the answers when you're graphing are fractions. Those are best solved a different way that we'll see in the coming days. But sometimes you do have to estimate it in between two values, and that's okay. Just do your best to estimate where they are. Okay. All right. So there's our solving systems using graphing. Got a couple different things that can happen. If the lines intersect, you can name the solution. If they overlap, it's infinite solutions. Or if they are parallel, it's no solution at all. Okay, all right, your first homework today is on Delta Math. There are some instructions on OneNote. So if you go to homework number 1 on Delta Math, you can click the link there if you'd like to. You should already have an account. You log in with your same rebuff information, and the assignment should be there waiting for you that you can go in and complete. There's 5 problems in each category. Just remember that once you finish a category, you need to back out and go to the next category. Getting those 5 problems, remember, means getting those 5 problems correct. So to get all the credit, you want to make sure you get 5 correct in each category. If you have any trouble at all, or if you're having problems getting the questions correct, please send me a message in the chat room, and I'll do my best to kind of take a look at what you're doing. I can see what you're getting wrong if I go look at it, and I will send you a message to try to help you out. You can also write the problem down and send me, a picture of what you're working on and how you're having trouble, and I can look at it that way. So please let me know if you have any problems, and best of luck to you all.